Hey everybody, and welcome to the video on adding and subtracting rational expressions. And in this case we're going to take a look with unlike denominators. So if you haven't had a chance to watch 7.3 video, especially on the LCD component, I would highly recommend that you go back and review that video on the LCDs, because we are going to use that information, so it's going to be assumed that you're already familiar with how to find the lowest common denominator, or at least have some experience / familiarity with it. So without further ado, all we're going to do is add and subtract rationals with unlike denominators. And here we got about 7 examples to work through is what I have slotted out. So let's get on without further ado. So let's take a look at our first example, which is 4n over m plus 3m over 8. So again, we'll take the m and the 8 and again try to get something that looks familiar, to get them to look exactly the same. So notice here we're missing an 8, and notice here we're missing an m. So notice that to get the common denominator on the bottom here, I'm just going to multiply this by an 8 down here. So we get our 8m. And so what I do to the bottom, I better make sure I do to the top. So we get 8 times 4n divided by 8m plus, and then coming back over here, notice that I have to multiply that 8 by an m. So again, if I multiply by an m here, I have to multiply by an m up here. So notice that we get 3m times m divided by 8m. So notice that gets us our common denominator. So then we can come over here and just write 8m. And then notice we have 8 times 4, so we get 32n plus 3m times m is 3m squared. And at this point in time, I'm not seeing any common factors up top to cancel out with the bottom. So I'm just going to call this the day. And this is going to be our final. All right, so for my next example, we'd like to take a look at 5 over x minus 2 minus 3 over 3x minus 6. So here I'm just going to bring up my x minus 2 here and a 3x minus 6 over here. And notice that for this side I got a 3, so I get an x minus 2. And on this side I have my x minus 2, so I'm just going to bring that down. So again, in order to get these things to look the same, I'm hoping that we can agree that, let's see, so this side is going to need a 3, right? And I don't really have much to do with the other side, so I'm not going to really do anything with the other side on the other side here. So coming back over here, I can rewrite this as 5 over x minus 2, and again I'm going to put my 3 here, and so I'm going to multiply by a 3 up here, minus 3 over, and here I get a 3 and my x minus 2 here. So now I come up and I have 3 times 5 is 15 minus 3 divided by 3 over x minus 2. And here I get 12 over 3x minus 2. And notice that the 3 goes into the 12 4 times. So I'm ending up with 4 over x minus 2. All right, so for example number 3, we get 2 over y squared minus y over 3y plus 1. So again, bringing the denominators over here, I get y squared and 3y plus 1. And notice there's nothing to factor on either side. And notice that since these are different, in order to get them to look the same, I will multiply the left side by 3y plus 1, and I will multiply the right side by a y squared. So notice that I have y squared times 3y plus 1. So up top I get 2 3y plus 1 minus, and then on the bottom I'm going to multiply by a y squared, so I get my 3y plus 1 times a y squared. So if I do that to the bottom, I have to do that up to the top. So I end up with this funky looking thing. So let's just note that on the bottom, I'm going to get y squared 3y plus 1. So I can go ahead and distribute the 2 across, so I get 6y plus 2 minus y cubed. So taking a peek see up here, there's nothing really to factor up here because I have a cubed. I got a linear y. Yeah, nothing's going to really work out on this one. So we'll just go ahead and leave that as such. Okay. So because there's not really much to do on that one. All right, so for our fourth example, let's take a look at this guy, 10 over x minus 7 plus 3. All right, so here we have to be careful when we have a rational with a whole. Remember, we can rewrite this as a 1. So let's just note I get x minus 7 and I get a 1. All right, so at the end of the day, to get my common denominator, notice on the right-hand side, I just have to multiply by x minus 7. So here I get 10 x minus 7 on the left side plus, and notice over here, if I'm going to multiply by 1 by x minus 7, then I have to multiply the top by x minus 7. Okay, so this becomes 10 over x minus 7 plus, and now I'll go ahead and distribute the 3 across, so we get 3x minus 21 over x minus 7. So now I can collapse this all with one denominator, so x minus 7, so I get 10 plus 3x minus 21. And now we can go ahead and collect like terms, so nothing to combine with the x. And here we get minus 11. And I'm going to put this over x minus 7. So the top does not factor, the bottom does not factor. So we are done for the day on that one. So for example 5 here, let's take a look at 11 over x minus 9 plus 3 over 9 minus x. So hopefully we can see with the denominator we're kind of off by a negative, so I get x minus 9 plus, and then we're going to take a look, not plus, then we get 9 minus x. So again, to flip this around, I'd like to go ahead and just flip this one around. I don't know, there's something about having the variables positive. So remember, we just factor out a negative, so we just write a minus, and then we flip these around like this. So in order to get these to look the same, notice that I have to multiply this x by minus 9 by a negative 1, so that we get a minus x minus 9 for our common denominator. So let's just note that if I multiply the bottom here by a negative, then I have to multiply the top by a negative. So I get that plus, and then notice we're just going to rewrite this as a minus x minus 9. Now, this is the way I'm showing you how to do this. Your author did one of these. It looks like about example 4 in your textbook. So you have two different ways of approaching this. At the end of the day, they're both going to work out to be the same way. All right, so the question then becomes, do you really have to do this? So I'll just leave it up to you. I'm just kind of running a procedure here. But notice that we have a negative over a negative, so this actually just becomes a positive x minus 9. And then notice that we have this negative down here. So remember, by equivalence, we can bring the negative up top, out front, and at the bottom line is this just, we'll just flip the sign. That's what it boils down to. So this negative, change that addition to a plus, and then notice that we just get 3 over x minus 9. And so at the end of the day, we get 11 minus 3 over x minus 9, and we know that 11 minus 3 is equal to 8 over x minus 9, and we are done for the day. Okay. All right, so I hope these are making sense. Again, if you need to, in order to keep the videos kind of relatively shorter, I am kind of picking up the pace a little bit, but I always feel as though you can always stop, rewind, and review if you need to. Okay, so I'm kind of keeping that in mind as well. Okay. All right, so this brings us down to example 6. So after this, we got one more. That last one has to be the doozy. Of course, not really. It is, but it isn't. So 9 over x minus 4 quantity squared plus 11 over x minus 4 times x plus 10. Okay, so let's take a look here again. So if we come up over here, I get x minus 4 squared, and we get x minus 4 and x plus 10. So I'm just going to rewrite this squared just to expand this. X minus 4, x minus 4, and then over here x minus 4, x plus 10. So let's just observe that we already have an x minus 4 here and here, so we don't have to worry about that. So notice what we're going to need on the left-hand side. We're missing an x plus 10, so let's put an x plus 10 here. And then notice we're missing an x minus 4 on this side, so let's just put that over there. All right, so let's come back over here. And we'll notice that we're going to have to multiply the denominator by x plus 10. So we get our x minus 4 squared. So I have to multiply the top by x plus 10. Plus, and then notice on this side, we had to multiply by an x minus 4. Okay, so here we're going to get x minus 4 times x minus 4. So we get x minus 4 squared times the x plus 10. So again, if I multiply the bottom by x minus 4, then we have to come up top and multiply by x minus 4. All right, so now we can go ahead and I'm going to distribute the 9. So I get 9x plus 90 over x plus 10, x minus 4 squared, plus, and then 11x minus 44 divided by x minus 4 squared, x plus 10. So now we're at the point we can go ahead and put this all over one denominator. So x plus 10, x minus 4 squared. And notice that I'm going to get 9x plus 90 plus 11x minus 44. So now our last step, x plus 10, x minus 4 squared. So 9x plus 11x is 20x, and 90 minus 44. So 90 minus 44, I came up with 46. Okay. So the only thing that I can do appears that I can factor a 2 out of the top, so I get a 10x plus 23 divided by x plus 10, x minus 4 squared. And here we have this in our totally factored form, and there's nothing to cancel out. All right, for my last example, we'd like to take a look at, let's see, 2x over x squared plus 7x plus 12 plus 3x over x squared minus 9. I'd like to take and factor these denominators, so 2x over, let's see, what about x plus 4, x plus 3, plus 3 over x plus 3, x minus 3. All right, so I think we could take a look-see and see what's missing on either side. Kind of take a shortcut here. So what's missing on the other side? So I think clearly on this left-hand side, we're definitely missing an x minus 3 over here. And if I take a look at the denominators here, looks like we're missing an x plus 4 here. Okay? So let's just observe that if I multiply this denominator by x minus 3, then I have to multiply the top by x minus 3. So we get x plus 4, x plus 3, x minus 3, plus, and if I multiply the bottom by x plus 4, then we have to multiply the top by x plus 4. So I get x plus 3, x minus 3, x plus 4. All right, so let's go ahead and distribute. So I get 2x squared minus 6x plus 3x plus 12 divided by x plus 4, x plus 3, x minus 3. So we get 2x squared minus 3x plus 12 over x plus 4, x minus 3, x plus 3. Let's see. There's no common factors. So let's see. 2 times 12 is 24. So is there any factors of 24 that will add up to a negative 3? So let's see. 1 and 24 are definitely not going to work. 2 and 12 are definitely not going to work. What about, I believe, 3 and 8? 8 times 3 is 24 still. Nothing adds up there. 24. What about, let's see. What about, 3, 4, 6 times 4. 6 times 4, do we get a negative 3 there? No, don't get a negative 3 there. 4, 5, 6, no. So it does not look to me as though this thing is going to factor. So it looks to me as though this is about it. Okay. All right, I hope that helps. And if you have any questions over any of these examples on the video, please feel free to go ahead and put those on your money points. I hope these help you out, and I will see you in the classroom. Thanks.